Glacier Peak Volcano. The state of Washington contains 7 volcanoes which are classified as active, the last of which erupted between 2004 and 2008. However, Mount St. Helens is not the only volcano which has erupted quite recently, as there is also a towering glacier cover peak which erupted approximately 324 years ago. The peak in question rises to 3,213 m or 10,543 feet above sea level. Due to the fact it contains more than a dozen glaciers, is referred to as Glacier Peak. Along with Mount Helens, Glacier Peak is the only volcano in the state of Washington to have produced multiple powerful plenum eruptions during the last 20,000 years, some of which were larger than the infamous 1980 eruption of Mount St. Helens. As a result, much like Mount Rainier, Glacier Peak has a large potential low-risk area since much of its glaciers could melt during the future eruption, placing up to 67,000 people at risk of being inundated by lethal AERs up to 71 miles away from its summit. The Glacier Peak volcano can be geologic setting found in north-central Washington, where it is centered 65 m east and northeast of the city of Seattle. Like other volcanoes in the Cascade Mountain range, Glacier Peak exists due to the offshore subduction of the one-day Foucault Plate underneath the North American Plate. The subducted ocean and crust from this collision then experiences partial melting, rising upwards to create magmatic intrusions, which goes on to form a chain of volcanoes. If you look at Glacier Peak eruptive history from satellite, you will note that it has an incredibly rugged appearance. Although this is partially due to explosive volcanic activity, it is primarily due to numerous glaciers which have carved out large portions of this mountain. Due to the numerous glaciations this volcano has experienced, much of its early geologic record is not well known. What we do know is that this volcano began forming sometime between 600,000 and 200,000 years ago, as this marks the age of its oldest radiometrically dated lava flow. These earliest eruptions were remarkably similar in composition to its more recent eruptions, creating mostly a volcanium eruptions which interwove thick, slow-moving, viscous dacite lava flows with layers of ash. These early eruptions built a central, albeit rugged, volcanic cone which was soon carved away by multiple cycles of glacial advance and retreat. Due to the ongoing ice age, the layers of ash were far more susceptible to erosion than the harder dacite level flows, resulting in the vast majority of ridges going away from Glacier Peak summit, representing high points on viscous lava flows. As Glacier Peak continued to grow with vents largely aligned on Earth, the cell trend, not all of its eruptions originated from its summit. 3 such eruptions during flank cinder cones the last 50,000 years create a series of separate cinder cones in spectacular Strombolian eruptions and placing lava flows that follow the low points and glacially carved valleys. The youngest of these vents is the White Chuck Cinder,